right? 30 June 2026. And we are live now. So I want you to write chapter 6.2. Okay, for 30 June 2026. This is our lesson for today. We will be covering chapter 6, part 2. Do you remember how your stage 9 science is like? It is how many chapters? 9. Okay? Stage 9 science has 9 topics. How many for bio? 3 for bio. How many for chem? 3 for chem. How many for physics? 3 for physics. 3 bio, 3 chem, 3 physics. For bio, it's chapter 1 and chapter 4 and chapter 7. For chemistry, chapter 2, chapter 5, chapter 8. For physics, chapter 3, chapter 6, chapter 9. So we are doing chapter 6, which is sound. And we are doing part 2. Okay, we are doing physics. Chapter 6, which is physics. And we are doing part 2. So we are doing sound. We are learning about sound. And we are doing part 2, which is interference of sound. Interference of sound. And what we want to see is how can we have two waves meeting and reinforcing each other. Two sound waves meeting and they make a louder sound. We can have two sounds meeting and they produce a louder sound. Or you can have two sounds meeting and they produce no sound. So we want to see, how does that happen? How can you have sound 1 and sound 2? They can meet and increase the volume, or they can meet and reduce the volume to nothing. So it depends with how the two sounds are going to bump into each other. They can either, we're going to see how they can either reinforce each other and make the sound louder, or they can cancel out the sound. Did you write 30 June 2026? Then you say interference of sound. Have you written that? Or we can go through it together and then you write when I share with you the notes, right? Then you can write them. All right, that's great. So let's see what you have to study in this topic. There are 5 things that you must know in this topic for you to say you are done with chapter 6.2. Chapter 6 has 5 parts, but the other parts are smaller. Part 1, part 2, they are a little bit big. Here we are doing only part 2. Then we'll do chapter 6, part 3, part 4, and part 5. You'll be done. You'll be on left with chapter 9 for physics. Remember, you only have 3 chapters to do. Only have 3 chapters to do. So it's not too much. Don't pretend like it's too much. So what you must know is, what is interference? This thing where we are talking about sound meeting and making a louder sound, or sound meeting and canceling each other out. So to cancel each other out, that means they will produce no sound. 0 sound. So interference, we want to see what it is. And the 2 types. Constructive, where you get a louder sound, and destructive, where you get no sound. Then we want to see the applications of interference. Real world examples where you have people in a church or in an assembly, and they are sitting and there are many speakers in the hall, and those speakers are meeting and they are making the sound louder so that people who are sitting in the church can hear nicely, or who are sitting in the auditorium can hear nicely. We'll see the applications of interference. Okay? Then we'll see some experiments that you can do to to check this interference, right? Have you seen the 5 parts? You should know what it is. Then you should do type 1 constructive, then type 2 destructive. Then you should do applications. Then you should do some experiments. Are we together? Good. Let's start. Okay. Let's start with here. What is the big idea of this chapter? Okay. We'll talk about these. The learning objectives is just the same as this, but they are just more open. You see them when you're writing. The big idea of the chapter is that whenever two sound waves are going to meet, when you have two sounds, we say sound waves. When two sound waves meet, they interfere. They interfere. They collide. It's like to collide. They don't just pass each other. When they meet, they are either going to cancel each other out or they are going to strengthen each other. They add onto each other or they remove from each other. So when two sound waves meet, what happens? There will be an interference. To interfere with somebody is to, you're going to affect them. Yes. Now, when they're doing the interference, it could be reinforcement where they make each other bigger, or it could be cancellation where they cancel each other out. And you should know that everything else we are going to be doing is from these two ideas. That when you have two sound waves meeting, they will interfere. Let's define interference. Interference is the effect produced when two waves meet each other. Same, it's like when two waves bump into each other. What you're going to get is interference. The effect, the result of two waves meeting each other. Okay? So it is the effect of two waves meeting each other. The effect produced when two waves meet each other is called interference. Two waves are meeting here. Look at it in green. Here again. Two waves are meeting. When they meet, look what's going on. That's what we call interference. That's interference in this region here where your waves are meeting. It is the effect produced when waves meet each other. Any type of wave. For us, we are going to study sound wave, but when we are defining, we are going to be giving you examples using water waves, any wave. But when we are going to now start looking at practical things, we'll talk about sound because we are only studying sound. But interference is the result of two waves meeting each other. Here is water waves. We are using it as an example. Yeah? You're going to have, let's say you have two fingers dipping into water. You're going to get both of them doing this effect that you're seeing here. Both fingers will do the effect you are seeing here. Where you dip a finger into water, you're going to have ripples. Ripples that spread outwards. Now, if you dip two fingers close to each other, then these ripples are going to overlap and make a new pattern. That is what we call interference. When waves meet, if waves are not meeting, don't talk about interference. It is going to happen when waves are meeting. Now, when we have what we call constructive interference, it is going to happen when two waves meet each other and they reinforce each other. To reinforce means to strengthen. Remember, whenever two waves meet, it's interference. Whether they are strengthening each other or not, it doesn't matter. As long as two waves meet, we have interference. But now we are seeing the two types. One is constructive. To construct is to make something. So when we have constructive interference, the waves are meeting each other and producing a larger wave. They're going to produce a larger wave. Now you say to me, how does that happen? How do we have two waves meeting and we get a larger wave? It's because when the two waves meet, they are in sync with each other. When you have a crest of one wave meeting a crest of another wave, crest is meeting crest. So they are going to support each other. Let me show you by diagram here. Look at this. Wave 1 has a crest at exactly the same position as wave 2. So these waves are meeting. If waves don't meet, there is no interference. These two waves are going to meet in reality. In real life, they will meet. If we are talking about water, it's those two ripples that we saw, they meet each other. And when they meet, they are in sync. They are at the same point. That's a good situation because they are agreeing with each other. Both of them are saying hi. Another one is also saying hi. So they'll make a bigger wave like this. And when they are low, it's also the same situation. It's two troughs. Remember, this is now called a trough. When we say we have a trough, it means we have the bottom of the wave. Look, it's at the same position. If we take a ruler, you can go straight down to meet the other trough. The troughs are in the same position. So these two waves are in sync. So this is constructive interference. So when I ask you, what is interference? You should tell us that it is the effect of two waves meeting. Then I ask you, what is constructive interference? It is when two peaks or two troughs arrive together and add such that they will reinforce each other. That's constructive interference. They will add and become bigger. Why are they becoming bigger? It is because they are in sync. Two peaks arrive together at the same time, or two troughs arrive together at the same time. So their amplitudes will add. They are not fighting. They are adding to one another and they will reinforce. That's constructive. Destructive interference, which is the second type, causes cancellation. Constructive causes reinforcement. To reinforce is to strengthen. Oh, we need to reinforce the team. We need to strengthen this team. We need to reinforce the police department. We need to bring more police officers. To reinforce is to strengthen it, to make it larger. But when you cancel out, this is destructive now. It's two waves are meeting. Yes, because it's a type of interference. We said interference, the two waves have to meet. But now, when they are causing destructive interference, that means they are out of sync. One is a peak, the other one is a trough. And these two waves are meeting. You have wave 1 is like this. Wave 2 is right below. When this one is a peak, right at the same position, this one will be a trough. So look, this one is maximum, then this one is minimum. So they'll cancel out and give 0. One is 5, the other one is -5. They will join to give 0. That's called cancellation. That's destructive interference. If they ask you to define it, you say it is where a point where crests of one wave meet troughs of another, such that the waves cancel each other out, creating flat waves. If we are dealing with waves, so Here's what we're saying. Conditions. Okay. Okay. I'll come back to this. Let's see here. I want to finish what I'm talking about. Constructive interference, we said it is when they reinforce or make each other stronger. Here is an example that I'm going to show you later on down the when we keep going down. People are in church. Can you see people in church or in an auditorium? And there are two speakers. The speakers are producing sound, and the sound will meet at the center and become louder so that the people sitting can hear nicely. So you can increase the volume by putting many speakers, because when you put many speakers, they will produce sound waves, and these sound waves are going to interfere or to meet, and if they interfere being in sync, they will do constructive interference. This is what sound engineers do. They practice this to make sure that the audience can hear nicely. Are we together? Exactly. This is an example of constructive interference. It's happening in churches. It is to produce a louder sound, right? So you have this peak meets peak, yes, or trough meets trough. You have constructive here. When two wave peaks arrive together, okay? This is what constructive interference is. It is when two peaks arrive together, or when two what? When two troughs arrive together, okay? Their amplitudes will add and the waves will reinforce each other and make a bigger combined wave. The combined wave should be bigger, like this. Are we together? Because they are in sync. Now, let's see what changes in constructive interference. The amplitude, does it increase? Yes. The new wave you are going to make, look at it. It has a bigger amplitude. Remember, amplitude is from equilibrium, this zero, to either the top or the bottom. This is your amplitude A. Or you can say this one is your amplitude. Okay. Amplitude and amplitude. Are we together? So the amplitudes will add and you get a bigger amplitude. Look here. This was a small amplitude, another small amplitude. Look at this one now. It's much bigger. This was a small one. This was a small one. They added to get a bigger one. This is a sign that constructive interference has happened. Are we together? But the frequency, I want you to know, frequency does not change, which means the pitch will not change, because pitch is affected by frequency. So you are not going to hear a person who is singing ho ho ho. You won't just hear them in church now being hi ho. The pitch has changed. No, the pitch doesn't change. When speakers meet, they just increase the loudness or the volume. Are we together? Because the amplitude affects loudness. Do you remember? Amplitude, this is from 6.1. Amplitude affects loudness. The frequency doesn't change because look, here, how many mountains did we have? We said frequency, you count the mountains or the valleys. Here we have mountain 1, mountain 2, mountain 3. So there were 3 mountains. Look at on both waves, 1, 2, 3. Even on the new one, sorry, the new one still has only 3 peaks. So the frequency doesn't change. What changes is the amplitude, which will mean the loudness. When there is constructive interference, the frequency doesn't change. we'll see it's going to be the same again for destructive interference. So the sound becomes louder. Amplitude determines loudness. The sound will become louder. It will be, then you hear it, yeah. It's because of reinforcement. Amplitude will increase and the sound will become louder. During constructive interference. Victorson, are we together? AT, are we together? Good. Here's the example of a concert. I'll fix the image. It didn't come out, but it is where you have people sitting, like I showed you, in an auditorium. We can use this diagram. The speakers are going to meet, and when the speakers meet, they will do constructive interference. The waves, they always meet in a way that you are going to hear louder sound. So there'll be constructive interference because the sound waves reinforce. Right. Okay? This is very important. I don't want to over explain. Now here is the second type of interference, which is called destructive interference. Two waves are meeting. These two waves are meeting, but they are meeting out of sync. You should tell people it is when they meet out of sync. One wave it's when a peak meets a trough. Do you agree with me? Yes, a peak meets a trough. Then you are going to have the amplitudes add to become zero. Because one is maximum up here, one is like this, so the result will be nothing. They add to become zero. They cancel the sound. They don't make it louder. They make it nothing. Normal sound. Here is what is happening. Look here, guys, students. One is a peak. At the same time that it is a peak, if you go down with the ruler straight down here, you see that wave number 2 is a what? Trough. This is a trough when the wave is at the bottom. This is a peak when the wave is at the top. So wave 1 is peak. At that same position and same time, wave 2 is a trough. So when they come together, they will cancel each other out. You get no sound at all. That's destructive. You are destroying. They are canceling out completely. Remember, these two waves are the same. They have the same power, but one is in negative, one is in positive, so they will fight and cancel out each other. Here, two waves can interfere to cancel when wave peaks of one wave meet troughs of another. This is what will happen. And you get cancellation. Flat line, zero amplitude. Because wave 1 was a peak, that wave 2 was a trough, so they will cancel, and this is what you get. Right. Here you have complete cancellation. We'll talk about it. Let me say something here that I want you all to know, and I don't want you to let me down. When you are doing cancellation, when you are doing interference, we have wave 1 and wave 2. But wave 1 and wave 2 should have certain things. Number 1, yes, they are out of sync, but they should have the same frequency. They should have the same frequency. We don't want to see wave 1 being like this. Look at it. Being like this. Up, down, 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 up. Then wave 2 being like this. Up, then down, then up, then down, then up. You cannot combine these two waves. They are different. The waves should have the same frequency and same amplitude. Amplitude now means the size. It should be the same. Then now we can start to talk about them meeting and affecting each other. So this is what we mean by the conditions for complete cancellation. The two waves must have the same frequency. Not one is like this, then the other, which means it has high frequency, then the other has low frequency. No, same frequency. And same amplitude. Not where one is big like this, then the other one is small like this. No. Same amplitude. And opposite phase means they are out of sync. One is a peak, one is a trough. Opposite phase will make them cancel out. Opposite phase, and you get complete cancellation. Where does this work? It works in these type of headphones. These are called noise cancelling headphones. They know how to cancel noise. So if you are wearing them, you don't hear outside noise. They use destructive interference or cancellation. So here, constructive, we said peak meets peak, and you get louder sound. Then we said for destructive, peak meets trough, you get silence. No sound. Zero sound. Are you fine with interference now? Good. Now what you need to know is applications. Here is application number 1, which I've already talked about. I said you're in church or in any concert, you have multiple speakers. Speaker A and speaker B will meet, and when they meet, they will reinforce each other, and the audience will be hearing a louder sound. So the sound will be great. They won't be saying, we can't hear. No. In constructive interference, they meet and they make the sound louder. Then noise cancelling headphones. This is now the example for destructive interference. Sound enters. Sound from the surroundings. But the sound from the surroundings, before it gets to your ears, there is going to be an anti-wave that's created. And this anti-wave is exactly the same as the sound wave that has entered, but it's opposite, it's antiphase, such that when sound is at 1000, it will be at negative 1000. And they will cancel, and you get silence at the ear. So you will not hear the noise from outside, because the noise cancelling headphones are removing it. Are we together? No more noise. Wow, that's good. That's good. Here comes the last part, which is the experiments. The 2 practical experiments you must know when it comes to checking interference. Are we together? Experiment number 1. Here's the apparatus. You need a tray. You need water. I'm going to make you write this first, I think. And then when I make you write this, then I'm going to be able to explain to you what goes on and what observations you see, what you should learn from each experiment. So I'm going to make you write, because I need you to write the apparatus. Once you write them, you begin to remember them, and everything will make sense. So I'm going to make you write the apparatus. Don't worry about the summary. I'll talk about it when we are together. But what I want you to know is that sound can go through interference when the sound waves meet. And when peak meets peak, you get constructive interference, either when peak meets peak or trough meets trough. Then other than that, you get destructive. But in the water wave, you'll be just having a tray and water and nails This is the setup, and you're going to work with them. I'm going to show you how you're going to do it. But please, here, can you just if where we're going to talk about how you hit them sideways so that they stick onto the wooden plank. This is exactly how you do it. You force them, then you dip them together into that water bath. When they dip into the water, they are going to create those waves, those ripples, and the ripples will meet. That is where you see interference. This is what you're going to see. The two nails, when you push this wooden thing, you push it down. Okay, here you push with your hand down. The two nails get into the water. Then they're going to create ripples, and the ripples will meet. You start to see some patterns and bands. This is where we have it. Okay. And here the second one, this second one, you're gonna need a tuning fork, and you'll be heating, and we're gonna be seeing what goes on here. I'll explain to you, okay? And we see the water, the reflection, the wave coming out because of this, the sound wave. But it's fine. What I want you to start doing is, I'm gonna give you an exercise that I want you to write, as well as these notes, and then we can continue with the next subject, which will be chemistry. Are we together? Victor 80, are we together? Okay, I'm going to send you 15 questions or so on interference, and I'm going to send you these notes in case you want to be checking, and then you write them and check and you answer. We meet again we're supposed to meet at 10. We can meet at 10:30, between 10:30 and 11, okay? Start writing the exercise, then you submit. You're dismissed. I'm sending the work right now.